In this video, we will dive deeper into the EEROS control system and take a closer look at the concept of signals and time domains. Let's talk about signals. A signal represents a sequence of time-varying physical quantities as used in signal processing and control. Signals are used to connect different blocks in the control system and exchange information between the control system, the sequencer, and the safety system. Each element of a signal is characterized by a value, a high-precision timestamp, a name, and additional properties which will provide semantic information. It is important to note that the signal can carry single values as well as vector or matrix values, and that the values can be logical or numerical. The timestamp provides the exact time that corresponds to the physical value of the signal. This is usually when the value was captured or generated. A common time base is crucial in control engineering because calculations with signals become incorrect if one of the signals is delayed relative to others. Some examples of semantic information are dimensions such as length, mass, current, etc. SI units such as meters or kilogram, or a reference coordinate system, or activation states such as activated, deactivated, and so on. Other properties could include information about the quality of the signal, such as noise or quantification, which could be used for Kalman filtering. Now let's have a look to time domains. Time domains consist of blocks that run with the same periodicity. A control system can have one or more time domains that run with different periods. When such a time domain is executed, each of its blocks run method runs in a predefined way. The order of the execution of blocks within a time domain is determined by the order of which the blocks are added to the time domain. A time domain can run in real time or non-real time. Time domains that are not executed in real time are triggered by external events. These events could, for example, be triggered by external cameras or a global navigation satellite system which provide data at their own clock rate. With this method, such asynchronously running sensor systems can also be well integrated into the EEROS control system. The temporal behavior of time domains that need to be called in real time is defined and executed by the executor. The safety system is also invoked by the executor and normally runs with the fastest clock. To realize a robust and simple system, the time domains run in harmonic and therefore in integer relation to each other. In this context, we say that they run in harmonic tasks. In the executor, you can define exactly how the time sequence takes place. In the example on the right, you can see that the safety system and the first two time domains run in the same clock, but the third runs as a harmonic task only with half the clock. An interesting question is what happens when signals flow from one time domain to another. Principally, signals cannot cross the time domain boundary because the signals from two different time domains lack a common time base. Therefore, it is necessary to connect two time domains via so-called transition blocks, which takes over the conversion and adaptation of the signals. Since the transition block is a member of two time domains, it also has two run methods. As a next step, go to the wiki.eeros.org website. Read the section Signals and Time Domains on the page EEROS Architecture Control System of the EEROS Wiki. If you have any questions, please ask them in the forum on the Moodle. As a next step, watch the next video that covers the topic EEROS control system, blocks, executor, and subsystems.